Hi, so let us start modeling of bending of a beam using the three roller configuration. So for that I go to part manager, part module, and in the part module I go to part manager, create. We are dealing with plane strain analysis, so the roller is going to be a 2D planar roller. So roller 2D. Now the rollers are going to be analytical rigid, so I select the type as analytical rigid. The approximate size is okay, continue. Now whenever we are creating an analytical surface in 2D, it doesn't allow us to create a complete circle in one go. So if I do want a circle, it has to be made in parts. So I select this option, select the center, select a point on the periphery, create an arc, then repeat the process for one last time. I'm having to create the circle in three parts because Abaqus imposes the constraint that the circular arc must be less than 180 degrees when we are creating an analytical rigid surface. So this is fine. Now I have to dimension it. I have said that the roller has a radius of 50 mm, so I enter that, fit to size. I'm good to go. So right click, cancel procedure, done. So now I have my roller. To see this as a nice circle, I go to view, part display options, curve refinement, extra fine. Now for all analytical rigid bodies we have to create reference point. So I go to tools, reference point, select the center as the reference point. Please remember that this is the point where the boundary conditions will be imposed. Next, let us create the beam. So I go to part manager, create. I name the part as a beam. It's a 2D planar, type deformable, base feature shell, approximate size. I'll take this to be 2000 now because my beam length is 1000 mm. Dismiss. So first I just create some rectangle, doesn't matter what it looks like. Then I'm going to dimension the thickness as 5 millimeters and the length is 1000 mm. Okay, cancel procedure, done. So my part creation is done. Now I go to the part property module. In here I'm going to create the material. First I have to create a material. So material is aluminum killed steel. Okay, its material density is 7.8 E minus 9. In this problem too, we are going to choose the units of newtons for force, millimeters for length, and seconds for time. And in these units, the density of steel, which normally in SI units is 7800 kg per meter cubed, it turns out to be 7.8 E minus 9. Elastic properties are 200,000 MPa and Poisson's ratio of 0.3. And plastic properties, so for the Swift power law hardening model we have to create a list of yield stress as a function of plastic strain. I have already done that, so I'm just going to copy that and paste it over here. Sorry, let's do this again. So I'm going to copy this and paste it over here. Now once the material is created, I create a section, solid homogeneous, made of aluminum killed steel of thickness 1 millimeter, and then assign this section to the part. Okay, so the part has turned green, so which means section assignment is completed. Next I go to assembly module. I bring the parts into the assembly. So I'm going to use instant type as dependent, so meshing will be done on parts. I'm using an auto offset feature. Okay, now I'm going to have to create 3 rollers, so done. So 3 rollers with a gap of 300 mm offset. I just need one of them, one row. Next I'll have to bring this part, okay, below these 2 rollers. So I select the part, done. I'll select this topmost point and first bring it over here. Then I select the part and move it down by 50 mm and forward by 20 mm, minus 50. Okay, so I have just placed it just below the 2 rollers. Then I'm going to move this one. I'm going to move it to left by, so this is 300, from here to here is 300, from here to the center will be 450, so minus 450, and I have to move it down by minus 105 mm. Okay, so if I do this, then I have the correct arrangement of the parts.